Okay, so let me give you a simple example. We may run a meta-analysis looking at religiosity and forgiving, right? And we've defined it well, we've thrown everything in, and let's say we want to do that as an ANOVA. So what we're going to do is have three different independent variables. Independent variable 1 is those that are fewer or greater than 100 participants. So we've force choice them. Remember, in an ANOVA, you have to have groups as your independent variable. So independent variable 1 is number of participants. Independent variable 2 is whether or not they use standard measures of religiosity or ones that the researcher created themselves. So we're just forcing it into two groups here, that's all. And then independent variable 3, did they control for other things like personality variables or anything else that's important, or do they have no controls in the study at all? And so now we actually have three independent variables, and we can run an ANOVA on our effect size to see if those three independent variables matter, each on their own and together even as far as research quality goes, to see whether or not we have a result. Looking at the same thing with regression on religiosity and forgiving, you could have the number of participants and actually put the actual number in, like I talked about in the last slide. And step 2, maybe you put in the Cronbach's alphas on the measurements of religiosity. And so you actually get your hands on the actual Cronbach's alphas, which is a measure of reliability. And then step 3 is a rating of controls on the study from low scaling up to high. So that's a continuum that you're looking at. So remember, in regression, you have to have continuums of variables, right? You can't have categories. So that's how you kind of make those same things categorical, or you can make them continuous, depending on what kind of ability you have to do that.